Today, we are slowing down time, minute by minute, to witness the very first day of human development. The journey starts the instant one sperm reaches the egg. Millions began the race, but only one is allowed inside. When that sperm touches the egg's outer surface, something incredible happens. A rapid chemical change sweeps across the egg's membrane, a protective wave that prevents any other sperm from entering. This is known as the cortical reaction, and it safeguards the egg from being fertilized twice. Inside the egg, the sperm head releases its genetic material. The egg also contains its own genetic material, stored safely inside its nucleus. For a moment, these two sets of DNA exist separately, two distinct spheres floating toward each other within the same cell. These are called the pronuclei, and when they finally meet, they merge into one complete and unique set of genetic instructions. Every trait, from eye color to blood type to thousands of unseen biological details, is now written into a brand new code. This marks the formation of a zygote, the very first cell of human development. With fertilization complete, the zygote enters its first major task, preparing to divide. During these early hours, the cell isn't growing in size. Instead, it is reorganizing its inner structures and checking its newly formed DNA. Tiny molecular machines begin copying the genetic material, ensuring both new cells will receive the same instructions. These preparations are slow, careful, and incredibly precise. Though nothing seems to be happening on the outside, the cell is working intensely on the inside, laying the foundation for every division that will follow. Somewhere between 6 and 12 hours after fertilization, the zygote completes its preparations. Its genetic material lines up nicely, internal fibers stretch and pull, and then the cell divides. What was once one cell becomes two identical cells. This moment is called the two-cell stage, and it marks the start of a rapid process called cleavage, a series of cell divisions that will continue throughout the first several days. Even at this early stage, both cells are already full of potential. Together, they hold all of the information needed to form every organ, every system, every feature of a future body. As time moves forward, each cell divides again. The embryo now contains 4 cells. They sit closely together, forming a small, stable structure. These cells are not growing bigger. Instead, they're becoming more numerous and more specialized in their potential. This unique pattern of division allows the embryo to remain tiny while increasing in complexity. This is also the time when the embryo begins its slow journey through the fallopian tube, gently moved along by tiny hair-like structures called cilia. Between 18 and 21 hours after fertilization, the embryo enters the 8-cell stage. Here, something important begins to happen. The cells start communicating with one another more actively. They exchange signals, adjust their positions, and strengthen their outer membranes. This communication is essential. It is the early foundation of teamwork between cells. Later in development, this teamwork will allow them to divide into different types. Cells that form the placenta, cells that create the nervous system, cells that become muscle, skin, and organs. But for now, everything remains simple. 8 small cells floating together inside a microscopic world. As the day progresses, the embryo continues dividing. Each of the 8 cells may divide again, bringing the total to somewhere between 8 and 16 cells by the end of the first day. This stage has sometimes been called the cleavage cluster. The embryo has still not implanted in the uterus. It is still traveling through the fallopian tube, and it is still incredibly small, far smaller than a grain of sand. Yet despite its size, the embryo is now a fully organized system. Every cell knows what to do. Every division is controlled. Every instruction is pulled from the same DNA code created at the moment of fertilization. Inside this tiny sphere of cells, the blueprint for an entire human body is quietly unfolding. At the end of the first 24 hours after fertilization, the embryo is in a stage we call early cleavage. It typically contains 2 cells, 4 cells, 8 cells, or up to 16 cells, depending on the timing of each division. All of these possibilities are normal. Although the embryo has changed dramatically in just one day, it remains incredibly small, microscopic, and invisible to the naked eye. Inside this delicate sphere of cells, the building blocks of life are already in motion. The embryo will continue traveling toward the uterus over the next few days. More divisions will occur, cells will begin to form specific groups, and the earliest layers of development will start to appear. In just a few days, the embryo will reach a stage called the blastocyst, and shortly after that, it will attempt implantation, the moment when pregnancy officially begins. But for now, we pause here, at the end of day 1, a day filled with precision, coordination, and quiet transformation. The first 24 hours after fertilization are complete, and a new biological story has begun.